Good evening, everybody. My name is Peter Taylor, and I currently work at the University of the Free State. My talk today draws attention to the importance of sound taxonomy to accurately documenting the diversity, endemism, and conservation threat of diverse yet highly threatened Afromontane ecosystems. Taxonomists like Charles Darwin, shown here, are often blamed for being preoccupied with describing obscure taxa like earthworms and being unaware of real-life problems. Yet evolutionary insights of systematic biology are critical to conserving biodiversity, and the so-called species problem coined by Darwin is very hotly debated and relevant to conservation today, as I will show. Let's take an example of African small mammals. These two graphs from a recent Mammalia article chart the trends in species descriptions of African bats and rodents per decade from the time of Linnaeus until the present. There was a peak at the turn of the century and early 20th century as colonial powers occupied new lands and made vast zoological collections that were documented in the great museums of the world, like the Natural History Museum in London. But during the remainder of the century, at least in mammalogy, there was a period of dormancy, in large part due to the paradigm of the biological species concept of Ernst Mayr, whereby species were clustered or grouped into sometimes geographically very widespread species or superspecies. But then in the last 2 decades, you can see there was an upswing in species description in these two groups. So between 1989 and 2018, we've seen an increase in species, and about 60 new species described in the last 20 years, with both rodents and bats. Some taxonomists have challenged this species splitting as taxonomic inflation rather than real speciation. So that's defined as raising subspecies to a species level based simply on a particular philosophy of species concept. So, for example, given the same data, a practitioner of the biological species concept would split or would lump populations into fewer species, whereas a practitioner of the phylogenetic species concept would split populations into more taxa. So, in a Nature paper in 2017, Garnett and Christides proposed or labeled this taxonomic inflation as taxonomic anarchy, which they said hampered conservation. It placed a burden on conservation, too many species to assess. They proposed a committee of the IUBS should decide on the number of species rather than taxonomists. So there have been a number of taxonomists that challenged this view. Papers such as Frank Zakos' paper in Mammalian Biology and Rasmus Heller's paper in Systematic Biology have challenged Colin Grove's 2011 book on ungulate taxonomy, which, using an evolutionary species concept, effectively proposed a doubling in the number of recognized ungulate or bovid species based on an evolutionary species concept. So these critiques were challenged by Colin Groves himself and some of his associates, who basically challenged the biological species concept dogma as being phonetic systematics based on arbitrary thresholds rather than using evolutionary principles and phylogenetic principles. And Colin Groves and some associates wrote in 2017 a useful review of species concepts, species definitions in the context of conservation. A review which I strongly recommend. So I'd like to give 2 brief examples from small mammals, and let you, the listeners, be the judge whether this is taxonomic anarchy or inconvenient truth for conservation. My first example concerns a group of African rodents of the genus Optimus, often called flay rats or laminate toothed rats owing to their unusual dentition. The ranges of these shaggy, short-tailed and vole-like rodents are closely associated with Africa's mountains, which have promoted their rapid speciation. And I want to just, there are 30 species in the genus, but I want to just talk about one, the Ethiopian vlei rat, or Otomus typus, which is found in, it occurs in isolated, shown here in yellow and turquoise. It's shown in isolated populations at very high alpine elevations, all the way from Malawi to Ethiopia. They share pallid coloration and particular features of the cranium, which were thought to unite these into one species, biological species. But as I'll show, these characters are in themselves convergent characters related to high altitude living that can evolve independently in different lineages. But a second biological species known as Otomus tropicalis is found at lower elevations in many of the same mountain ranges. And under the biological species concept dogma of the late 20th century, authors like Bowman proposed that there were two separate widespread radiations, separate in time, in evolutionary time, of lower and higher elevation species, which gave rise to these very widespread tropicalis and typus species. Michael Carlton of the Smithsonian Museum, one of the authors of the 2 volumes of Mammal Species of the World, challenged this dogma. He worked on this group and he predicted that speciation in these very sedentary rodents was more likely to occur along longitudinal ecological gradients and between neighboring mountain ranges, rather than across very widely varying mountain ranges across the African continent. Especially since the formation of many of these Rift Valley volcanic mountains is very recent in geological times, in the last 2 million years. So I was fortunate to work with Michael Carlton in an integrated study using molecular, chromosomal and morphological characters, where our molecular phylogeny, shown here in very simplistic terms, showed or confirmed his prediction, Michael Carlton's prediction, that speciation would occur on the same or adjacent mountain ranges across elevational gradients in the last 1 to 2 million years. So, for example, if we just look at one well-supported clade represented by 2 populations, a high and a low altitude population on Mount Elgon, and then a neighboring population from Mount Kenya. So our results suggested that some of these distinct mountain species were highly range restricted, probably threatened by climate and anthropogenic change. Just to take one example from Ethiopia, the species Cheesman's vlei rat, which we described from the Lake Tana area of Ethiopia in 2011, and based on historical museum records, of course, which were probably collected at the beginning of the 20th century. So Joseph Breyer and his colleagues were not able to, in surveys they did, published in 2019, they were unable to locate any extant populations of the species, indicating its probable extinction. The second example is closer to home. It concerns the forest shrews of the genus Myosaurix. The dark-footed forest shrew, Myosaurix kaifa, was previously thought to extend from the Eastern Cape to Limpopo and Eastern Zimbabwean highlands. Recent research showed that the Zimbabwean and the Limpopo Soutpansberg populations were distinct species, restricting the range of Myosaurix kaifa to South Africa, to the Eastern Cape, KwaZulu-Natal, and Eswatini. So what are the implications for climate change and conservation? Just briefly taking that last example, based on the revised distribution of Myosaurix kaifa and these species distribution models, which were projected using Maxent in different climate scenarios, to reveal that by 2050 the distribution of the species will have contracted, and we expect even further contractions because of anthropogenic threats and land cover and land use transformation that's ongoing in these areas. So based on this evidence, we expect Myosaurix kaifa to suffer future declines of at least 41 to 48%. And these data were used in the 2016 South African mammal red list to uplist Myosaurus caper from least concern to vulnerable. This is an example of how taxonomists and conservationists can work together very closely to come up with accurate depictions and assessments of conservation status of species. So, in conclusion, taxonomy matters to conservation. And whether you're a small mammal, a elephant, or an earthworm. I've tried to show that the Afromontane regions are centers of high rates of speciation across this montane archipelago. And this is true not just small mammals, but many other groups. And these taxa these regions have high endemism and a number of range-restricted species, endemic species that need conservation attention. I believe that taxonomy is a scientific process that is adequate for species recognition for conservation purposes, and that more dialogue is needed between conservationists and taxonomists. This was well illustrated by the partnership of taxonomists and systematists that resulted in the 2016 African Small Mammal Red List document. And also currently the Global Small Mammal Group is working very closely with taxonomists in revising international IUCN status. So if it's possible for small mammals, I believe that there should be greater engagement in conservation committees and panels by including specialists and taxonomists who are able to provide meaningful insights. So I thank you for listening to my talk, and if you have any questions, I'm happy to answer them.